In this video, I wanted to talk about pre-war Rolls-Royce charging systems. A lot of people don't understand how they operate. They don't have a lot of faith in them. I know a lot of people think that they weren't good from the beginning, and they add alternators and voltage regulators and end up causing themselves more trouble than what it's really worth. The original setup is perfectly fine. I've operated my car, which is what we're looking at here, for about 30 years on its original charging system and driven it probably 25,000 miles. And I can say that I don't really have any complaint about how it works. So anyway, my car is, mechanically, it's in really good condition. It's been rewired. The engine was rebuilt about 30 years ago. It runs nicely. I'll get in it and drive it just about anywhere at any time. The British might refer to a car like this as an oily rag, and that's kind of what it is, because cosmetically it's pretty much unrestored. You'll see that the interior looks a little shabby, and the exterior does as well. So anyway, now my particular car, mine's a 34 2025, and I have a 2-rate charging system. So it has, on the switch box, a summer and a winter on the ignition. So I guess the thinking behind it was that in winter, in the colder weather, you needed to have more power going to the battery to keep it replenished than you did in summer. So the winter output is higher than the summer output. And also that can prevent you from, on a very long trip, you can turn it down to summer and prevent you from overcharging the battery, which was more of a problem back in the old day, since the batteries were a lot more primitive and you could actually boil out the electrolyte and cause it damage that way. So to start off with, I want to explain to people sort of the operation of the ammeter and what you can expect out of the system. So if we start turning circuits on, we notice that the ammeter deflects. Sure, I'm getting maybe I'll turn the light on. So okay, so just turning on the instrument light a little bit, you see it deflects about 1 amp or so. Turn the ignition on, we get about another discharge of a couple more amps. We don't want to leave the ignition on because that can damage the coil when the engine's not running. So anyway, so we'll turn that off for now, and we'll turn this off as well. But then we go on to heavier circuits. So we have side lights. It's using up about 2 amps, side and tail, head, side, and tail. Now we're using up about 12 amps. And if we add the ignition onto that, then we bring it up another 2 to about 14 or 15. Step on the brake, turn on the brake lights, and then that's going to cause even more of a discharge. So when we kind of add these numbers up, oh, and another thing I'll show you is mine has electrically operated solenoids for dipping the headlights, which is kind of like a different version of high beam and low beam. We press that down and it really discharges because they take a lot of energy. And that was really only meant to be used when you were passing a car. So you wouldn't have it on low beam like you would very often. So we start turning things off, and then we notice that we get her back down to 0. So now when we start the engine, I have it on summer now, so that's the lower charging rate. I accelerate and it comes up a little bit. It gets sort of in the 1 to 2 amp range. We go up into the winter, goes up more. And then we can get it up to where I like these charging systems to be more like in the 7, 8, really no more than 10 when there's no load. Then we start adding circuits turn on the sides. We're still charging, but we have cut back a bit. Turn on the headlights. And this is just as we would expect. We're barely discharging. And so when we do our math, we realize that the amount of discharge we had from the headlights being on when the engine wasn't running has been compensated for by the charging system. So now, some people see that and they think, oh geez, I'm discharging. My battery's going to be dead in about 20 minutes or so. And well, that's just not true. You can go quite a long distance on a 2 or 3 amp discharge. Definitely more than enough to get you through a nighttime journey. So, and then we can also add the fact that if we'd have wipers on or a fog light or anything else, we're even going to be discharging more. And we also have a momentary contact for the instrument lights so that we don't need to have them on all the time, but we can if we want to. So anyway, we're sort of mining our ammeter as we're operating the car. And then we bring it down to a really low idle, and we'll notice that, again, it has a difficult time. You know, it's usually going to be around the 0 range. And just because it's there for a little while isn't going to hurt anything, because most of the time you're going to be going down the road at a higher RPM, somewhere around there, and you're going to be charging your battery. So by the time you figure out all this, when the battery is charging and when the battery is not charging, stop and go traffic and everything else, you're still going to be in good shape, even though you don't think so, because you're used to a more modern car that even at a low idle, you're charging the battery to some degree. But in this case, with these cars, that doesn't happen. So if you find that there is a fault with your charging system, in other words, you don't see any positive charge on your ammeter, it's just staying either in the negative or at 0, then I'm going to tell you a few things to check out. So the first thing you do is you always start with your fuse panel and you check your fuses. So now the fuses for charging system are this one, and then this cartridge fuse, glass cartridge fuse. This is the field fuse, and it is only supposed to be about a 4 to 5 amp fuse. It's only has the negative side of the field going through it, which is a very small amount of current, but it's enough of a grounding current to create a circuit for the charging system. So now in this case, this is an original one, and you'll notice that they're a little fatter than most cartridge fuses you see. It's either 5/16 or 3/8. But fuses that you normally get nowadays are 1/4 inch. So you may need to find an adapter. In my case, I have an adapter on a spare fuse there. I only have one. I should have the other one on there. I guess it fell off at some time. And you also should have a bobbin in there, and it's going to have fuse wire on it. And then you'll have a clip for a spare harp fuse. And then you have a basic diagram for what's going on where in your fuse panel cover. So, and then the other device that you have in your fuse panel is the cutout. Now, a lot of people call that a voltage regulator. It does not do any regulating of any voltage. It is only merely, as it is described in the handbook, as an automatic switch. So what happens is, when the dynamo is spinning fast enough that it's creating enough of a charge to replenish the battery, then the cutout closes. There's two windings. The smaller winding, it gets energized, it brings it in and makes the contacts come together. See if we can see them right in there. And then your charging system begins to work. So now this is a pretty fragile device, so you have to be very, very careful with it. The winding, there's about 1,500 turns of magnet wire, which is a wire with an enamel coating. And that wire, I think, is like 5,000, 6,000 thick, which is, you know, like the thickness of a human hair. Then you have a stronger winding. So the idea is for the smaller winding, pulls the contacts together, and then once those are energized, then the larger winding holds it in. So now the cutout, the contacts of the cutout, which hopefully you can see right in there, need to be opened enough so that they're not touching. That's the air gap. If they're too wide, then the cutout might not be strong enough to pull it in and make contact at those contacts. So there's a little adjustment nut and screw right there. The screw is actually the adjuster, the nut is the lock. And you may need to adjust that a little bit to bring those contacts in closer. I don't recommend cleaning those contacts because they're platinum. Platinum's very expensive and very soft. If you do want to clean them, just use a piece of paper, put them in between there, and rub it very gently. So another component we have, since my car has the 2-rate charging system, we have this resistor up here, this triangular shaped resistor. And one side of the resistor is winter and the other side is summer. And that is a resistance wire that's wound in there. Hopefully you can see it in there hiding. And it actually gives you the lengths of those wires when they're unwound on a little tab right in there. So I think one's like 15 inches and the other one's 9 or something like that. I think it may tell you in the book too. But a resistance wire is in this case, nichrome is a resistance wire. You can Google that. I think that back then they were using a nickel wire though. So, and again, the field current is going through these. And so the stronger the field, the stronger the energy in the field, the more power that's going to be going to the battery. The weaker the field, the less the charge output is. So that's what you're doing. The resistor cuts back on some of the energy that's going through the field coils of the generator. So another interesting fact with a 3-brush generator is that if you have a really strong, well-charged, newer battery, you're going to have a higher charging rate, which is not really all that desirable, I would say. But it confuses people to some degree. Now, if you put in a weaker battery, or if your battery's low, then you'll have a lower charging rate. And again, that's not an ideal situation, but it is the situation with a 3-brush generator that's very common. So, and another thing, you know, a lot of people, they'll see that and they'll think, well, I got to put a voltage regulator on. And there's a lot of people that do, and it works out fine for them. But I don't like that idea. If your voltage regulator isn't the right value, you can tax out your generator and burn it up and make a terrible mess of it. And those are very expensive to get rewound and repaired and all. And you definitely don't want to have to go through that. So, and also, you know, it's kind of neat to have the switch box and while you're driving along to think about something. You know, it gives you something to do. You know, let's put it on winter charge for a little while, and we don't. We are the voltage regulator. We're part of the operator of the car. So now I'm going to start it up, and I'm going to show you how the battery cutout or the generator cutout works. jack tools here. So we look, and the cutout is currently closed, and so that means the generator is charging the battery. So now I turn the idle down quite a bit, and I believe the cutout is now opened. And then I'm going to accelerate. Cutout's now closed. I don't know if you can quite see that or not. Let me see if I can. Okay, so yeah, so the cutout's now open. Let's see if I can accelerate past here. Cutout open. And you can see the cutout close. Okay, so now we're doing some testing of the generator on the car while it's running. There's our voltmeter going along there. So now what I've done was I've disconnected the wires going to the generator from the car, and I made sure that they're going to be insulated, because if they touch the engine or something and short out, then you're in big trouble basically. Then there's a jumper wire going from this terminal to that terminal, so that's going to be jumpering the B and the C. So those two are jumpered, and then you have the positive lead of the voltmeter connected to that, and then the one on the underside, which is the A, is going to the negative of the voltmeter. So now this is something that you have to be incredibly careful with in doing. Make sure you get your terminals corrected properly, and that you are sure that these wires aren't going to touch anything and short out. And then I'm going to show you another thing. As you can tell, I'm at a fairly low idle, and I'm doing about 19 to 20 volts there. And then upon acceleration, even with a small amount of acceleration, it comes up very, very high. And that's because the dynamo is being full fielded, meaning that there's the faster the generator turns, the more energy is going through the field coils. The more energy that's at the field coils, the higher the output. So that's why we have the resistor to control that. So again, if you're not terribly good with electrics or mechanical things, then get a friend who is, and have him do this, or her, and you can get an idea of the working of your generator. Now, there are no exact numbers. There's no exact numbers with this method of testing, but if you get similar results as to what I had, or have here, then your generator is probably in good working order. And if you still have a problem, then you need to go back to your fuses and your wiring and check all those things out. So anyway, that's what I call a simple sort of quick test you can do. Another thing you can do is you can do a similar setup, but you can actually turn the generator. You can get the generator off of the car, put it on the bench, spin it with a drill and connect it to a voltmeter, and you can get similar results. And if you spin the generator at about 800 RPM, you'll get somewhere about, I would say, 17 to 22 to 23 volts coming out of it. And you'll also feel on the drill, it'll load up on you. It'll make, you know, you'll feel the drill working to turn it. So anyway, that's sort of my down and dirty quick test. And wanted to show you that, how that works. So I have a voltmeter connected, and I just wanted to show you the action of the voltmeter with the charging system. Right now my battery is a little low. I haven't been using the car much for a while, and I'd been doing a lot of cranking and everything else. So you'll notice, and it's probably not putting out any charge from the generator at all. The voltmeter is just reading basically the battery and what little bit is being drawn from the battery for the ignition system. So, you know, we pick up the RPM. Charging rate starts to increase. And you may be thinking, well, that's a very small increase. Was it really doing anything? But, you know, if you keep watching it long enough, you'll see that it keeps going up to a higher number. You know, it takes a little bit of doing. You know, eventually it's going to get to 85 and then 86 and just keep bringing the number up. So that means that it's charging. It's putting electrical current back into the battery. And we look at our ammeter and we can see that that's showing a charge as well. So we keep running it like this, and then the numbers are just going to keep going higher and higher, and you're going to be bringing the voltage up, and until you finally get to a fully charged battery, which is I think something like 12.3 or something. So now that might not behave like a modern charging system, but it behaves adequately enough to keep the car going along, which a lot of people are skeptical about, but it's true.